Good evening, this is Firefly on Orodi Airfield on Guam, here on our multiplayer server of the Virtual Carrier Task Force 58. Today I want to show you how to plot a course and the distance for a flight using the Mark III plotting board that the US Navy used in World War II. And in later videos, walk you through other steps used in flight planning using the plotting board. So we are tasked with flying from here, from Orodi Airfield to Islay Airfield on the island of Saipan in the north. And the first thing is to look up the coordinates from where we take off from and our destination, and then how to use the plotting board to actually get the course and the distance to our destination. Let's have a look at the map. When planning this flight, we have to find both the origin and the destination on the map. For example, here in the F10 map view in DCS, we are taking off from Orodi Airfield and then fly roughly northeastwards the island of Saipan, where we want to land at our destination of Islay Field. In order to get the coordinates of both locations, in DCS we just scroll down there close to this part, and actually I want to take off from Orodi and then take a right turn just about when we leave the peninsula here. So approximately at this location. And in order to get the geographic coordinates for this location, you just look at the bottom left part of the screen in this status bar here. And here you can see the coordinates. It says north 13 degrees and roughly 27 minutes, and east 144 degrees and about 37 degrees. So this is how we get these coordinates, and we would do the same for Islay Airfield. We zoom in and then go here, and then again we read the coordinates from the bottom status bar. And this information we can use to plot the course and the distance with the plotting board, but of course in DCS you could also just use the ruler tool here for measuring this, and it says about 120 nautical miles at a heading of 34 or 33 degrees to Islay Airfield. Now, after having opened the plotting board app, we just add the coordinates of our origin, Orodi Airfield, and the coordinates of our destination, and start constructing the plot first. At first, we have to get the mid-longitude. And here we see the numbers, and basically you just take the average of both or decide for either one of them. So I would say 144.37, 145.43. I decide just to put the center of the plot at 144 degrees east. (144 degrees east). This is the first thing we have to do. Then we have to get the mid-latitude. So it's between 1327 and 1507. So I would just take 14 as the mid-latitude. And in order to do that, I have to turn the disk for 14 degrees. We are, it's The mid-latitude is 14 degrees north, so I have to turn the disk to the right. From 90 here, 100 is 10, 1, 2, 3, 4. Here. And this place I mark again with text. 14 degrees north. I also mark the latitude line. That I get after the rotation. Then I turn back the disk, and now I mark the latitudes in the appropriate positions. 15 degrees north is 1, 10, 20, 30, 40, 50, 60 degrees further north. And this is enough. If we look on our coordinates here, well, maybe not enough. Put one more, 13 degrees here, 10, 20, 30, 40, 50, 60. No way that we can still read it. 13 degrees north. Now I also mark the longitudes along this line here. So we have one here at 60 degrees east of 144 degrees is 145 degrees east. Put here. And let's do one more. At 120 degrees east of 144. Put down 146 degrees east. And now everything along this line here, not just straight above this intersection here, are all the locations at 145 degrees east. For example, here 15 degrees north and 145 degrees east would be exactly here. Now we add our locations to the plot. O'Rourke Airfield at 1327 and 144.37. This is the longitude I mark first. (144 and 37). Here's 30 degrees, here's 40 out here. And 1327, 13 was here. To this location, so it would be here. Correct? No, 13 and then 27. 10, 20, and 7 about here. This would be the point for O'Rourke Airfield. Let's find Isley Field. First, again, the intersection with our line, 145, 43, and 20, 30, 40, and 43. So here would be 5 to the left. 20, 30, 40, yes. And idle field, 15:07, 15 degrees and 07 minutes. Here would be 15:10, 15:07 would be here. Now we have both locations plotted. We can connect them with a line. This will be our course. So now we only need to measure the course and the distance. And we can do this by just turning the disk again until all the lines are parallel to the line we just drew between Orodi and Isley. And now let's check out. So this, and get it exactly aligned. So this, if we just take this as parallel, now we read here our course, the true course, 31, 2, 3. So this would be 34 degrees. Course is here. But it was not exactly parallel. If we take this as parallel, it would be 33. 33 degrees. So course is, according to our plot here, in the middle between 33 and 34. So we take just maybe 33 degrees as our heading, and the distance we can measure just by looking at the numbers here. Here we are at, is it 40, maybe 43 nautical miles, and the other one is in the other direction here, 70 and maybe 77. 77, I can even add this up here, 77. So it's 110 plus 10 equals 120 nautical miles. I'll just put this somewhere here, and the result is here at our distance in miles. So sure at the moment where to put this, but put it here. So 120 nautical miles, and that's what we get with our online tools or measuring in DCS. In the map view, it was also 33 degrees and 120 nautical miles. So this is how you plot the course and the distance just using the plotting board based on the coordinates you got with the mission briefing.